Okay, now we should also be recording. Over time, we'll build this out into a full series covering many of the actual aspects of technical use of OMOP for doing observational research. So we really move beyond our initial introduction on what OMOP is and sort of the context into the fundamental piece of using the vocabulary today. And so just as sort of historical reminder, this is the second in this extended OMOP series. The previous seminar was June 2024, which was our more basic overall introduction to OMOP. So if this is a totally new topic for you, I'd invite you to go back and watch that seminar recording from last summer. And so maybe just as a reminder and again, overall context, OMOP stands for the Observational Medical Outcomes Partnership. This was an initiative started in 2008 as a public-private partnership between the foundation of the NIH and the FDA and the pharma trade group, really focused on improving, enhancing observational data collection and utilization for things like phase 4 drug safety and surveillance topics. In addition to just data pieces, there are a lot of methodologic and infrastructure pieces that went along with this. That was essentially a 5-year project that ended in 2013 with a feeling that it was overall a success. And then just a semantic piece that is important. As of 2014, the group OMOP changed their name to Odyssey, the Observational Health Data Science and Informatics organization. And from then on, OMOP, rather than being a group, is what the actual database and data model is referred to. So historically, this gets a little confusing, but typically when you hear people talking about OMOP today, we're actually talking about the database, the data model, as opposed to the group. As sort of larger context on data models, if you're sort of new to the topic of data modeling or data models, this is an important topic because as electronic health records have proliferated, they haven't really proliferated somewhat monolithically. There are obviously different vendors of EHRs with lots of different proprietary functionalities. But even within EHRs deployed by the same vendor, there are many different local install aspects, which results in EHR data between sites or even between hospitals, very closely related to each other, essentially having EHR data that is either extremely difficult or really not possible to integrate together. One solution to that, and now probably the most common solution, is common data models. So this is really a sort of logical piece that takes the very highly customized, localized data models that databases are based on and standardizes them such that data can be extracted, standardized, turned into a common format, and then integrated together. And so the analogy that I've used here is that it's sort of like juicing. So you have all of these many different varieties of delicious fruits all across these many different hospital sites. The common data model is sort of like your juicer, which can sort of input and then combine and output a sort of standardized product that is enjoyable by all without having to worry about the differential minute pieces, between each. So sort of moving on now to the new topics of the OMOP vocabulary. The OMOP vocabulary is an incredibly fundamental piece. And also, I would say, for people used to doing observational research out of existing terminologies, maybe a somewhat challenging piece because of its difference compared to the way sort of other standardized terminologies work. So the first piece, just from a sort of glossary perspective, in OMOP, the vocabulary is more than just sort of a semantic, or a term. When we talk about the vocabulary, it's really the OMOP common vocabulary model, which is the way that Odyssey has worked really from an informatics and an information organization theory perspective to take many existing healthcare data terminologies and integrate it into a common, standard, unified information product. There are a couple of key things to know. So one is the OMOP vocabulary is not really ever considered finished. It is released as versions over time. So both the common data model itself, as well as the vocabulary, essentially receive updates and modifications over time and get specific releases. Also, it is perhaps helpful to know that the release versions are not synced between the vocabulary and the common data model. So for instance, the vocabulary, I believe, is currently at 5.0 as the most recent, whereas the CDM is at 5.4. So updates and work on those can happen somewhat out of sync. I guess another piece to just sort of state for reference is understanding and using vocab is really maybe about the most fundamental part of using OMOP. And as you may come to see, I think of the OMOP vocabulary, or maybe OMOP generally, being a very informatics and information theory forward data model, particularly compared to sort of existing healthcare databases and their use. So I think the place to start getting into the technical details is actually from the OMOP data model. So this is a visualization of the data model itself. The big box on the far left, where several of the boxes are outlined in red, these are the standardized clinical data tables. This is actually where the data, the EHR data itself lives. The box in the middle, where several tables are outlined in yellow, is the standardized vocabulary set of tables. So these are the tables that essentially constitute the OMOP vocabulary. So I am also calling out two subsets of these more specifically. The concept and the vocabulary, which I am labeling as more terminology focused. And then the several other about 6 tables below, which I'm calling ontology. This is a really crucial aspect of how OMOP works and how the information is designed and organized. And I think to really get into this, we have to talk about terminology versus ontology, because this is so fundamental to OMOP. So, there's a table here really talking about an ontology versus a terminology, as well as this list of healthcare standardized terminologies, ICD, HCPCS level 1, 2, LINC-RX norm, as well as common ontologies. I think ontology is a term that is somewhat colloquially used sometimes to just sort of loosely refer to a body of knowledge. But really from an information organization perspective, an ontology is a pretty specific structure that focuses on organizing information in a much more comprehensive and typically complex way than, say, a controlled vocabulary or a terminology. So if you think of something like ICD as a terminology, controlled vocabulary, that's really represented as a list. So, a term, a controlled term, is sort of reviewed and approved to codify a standard, set of information or a topic. And there can be sort of groupings or families that exist within that terminology. But the terminology is lacking the extensive set of metadata, for instance, to represent relationships between, say, one code and another code, or between one code and codes that come above it or below it. And so this is where ontologies, whereas terminologies are typically represented as a table or a list. Ontologies, if you're going to display them graphically, are really more of a graph structure. And I think this is where often ontologies often come into play with knowledge graphs. And so you're thinking of a much more network style representation with edges, nodes, vertices, all of the sort of structures that show much more complex hierarchical and interrelated relationships than you would get from the tabular structure of a terminology. And we're not going to go too far down to this. I kind of consider using OMOP as an ontology to be more of an advanced OMOP topic. So it's important to know that this exists and that OMOP is an ontology, and that comes into play sometimes. But if this is not incredibly clear, it will not affect, I think, your ability to get usable information out of the rest of this talk. So going back now to thinking about the OMOP vocabulary, more just from a terminology piece. So we've recognized OMOP is an ontology. There are many tables that add the ontological structure. But now we're just going to go back and look at those two tables I delineated as terminology focused. So OMOP vocabulary and OMOP concept. So first, the OMOP vocabulary table. This is the table that really represents in the OMOP data model which of the common healthcare standardized terminologies are being included in that release of the OMOP vocabulary. So here is just a snapshot. I want to say this is an earlier version of the vocab table. This is maybe 4.7 or 4.8, something like that. And this is just about the top 20 rows from that table. So you can see, select star from OMOP dot vocabulary, and then we have the vocabulary ID, which represents what the actual terminology is. So you can see some common things in here like ATC, CPT4, DRG, HCPCS. In addition to the vocabulary reference and the version. You can also see several different vocabs that are called OMOP generated. That is because not only is OMOP bringing in lots of already pre-existing terminologies, but there are some aspects of the vocabulary that are necessary and not handled by existing terminologies. And so they do create some portions of the vocabulary native to OMOP and used within OMOP. And then on the right-hand side, you can see, as of this release, a breakdown of the various vocabularies that are actually included in the OMOP vocabulary, as well as that stacked chart kind of showing the relative composition of the overall vocabulary pegged to each individual controlled vocabulary that's coming in. So I think the main point here is that the way OMOP vocabulary is structured and works is to really take as many of the existing healthcare terminologies that are more specific or generally used and integrate that into one common structure and vocabulary. And the place to get information on that at a high level is out of the vocabulary table. So now we move from the vocabulary table to the concept table. The concept table is where the rubber really meets the road in terms of OMOP and the generation of actual usable code types of concepts for OMOP. So the concept table is essentially the result of mapping all of those existing terminologies onto largely SNOMED as the default syntax, and then generating new concepts where OMOP concepts are the atomic units that are used to codify information inside of OMOP. So what that essentially means is every individual code in every individual vocabulary that's brought in and integrated into OMOP has to be mapped into a discrete OMOP code, which is termed a concept. And those concepts are largely based on SNOMED, if that provides any additional sort of reference or assistance in sort of understanding concepts. This is incredibly important because almost everything in OMOP is defined based on concepts. And this also means that if you're working with the concept table, it is a giant table. It's typically several million rows long because obviously its job is to take every source code and translate it into a concept. So obviously a very, very large table. The other piece to know is that every clinical data table in OMOP essentially relies on OMOP concepts. So take condition occurrence where largely diagnoses flow into all of those diagnoses, whatever they're defined in source, whether that's ICD-9, ICD-10, Nebraska lexicon, those are all going to exist in the condition occurrence in the mapped OMOP concepts. And so this is where having an understanding of both the source and how the source flows to the concepts, and how you get from, say, a definition in a source to a definition in concepts to then apply to OMOP really starts to become important. So what does a concept look like? This is an example of one OMOP concept along with the metadata that would exist with it in the concept table. So if you take, here, this is an example of a diagnosis of atrial fibrillation. This is actually bringing it in from SNOMED. So this is going to be based not on a source of something like ICD, but a source of SNOMED, and then mapping it into the OMOP concepts. So there's less mapping there from SNOMED to OMOP than, say, a more distant terminology. But you can see you get a concept ID. That's the primary key for each concept. Those are essentially random. So it is not like, maybe ICD, where like diagnosis IDs or ICD codes are sort of grouped together. Within OMOP, these are far more random. So it is highly possible that, say, concept ID 313218 is in no way related to atrial fibrillation. But so you can see you have the concept ID is your PK. You have the concept name. So that's the standardized text description that would exist for the OMOP concept in the concept table. You get the domain ID, which really relates to what OMOP table would I likely find this in. So here, this is likely going to show up in the condition occurrence table. And then you start to get some information about the vocab source that this concept is getting mapped in from. So this is coming from SNOMED. Within SNOMED, it's a class of a clinical finding. And then concept code is one of the terms that OMOP uses to identify the source. So were this an ICD code, that concept code would be the actual ICD code, and then a valid start date for the code, a valid end date, and any reasons that this code is invalid or any situations where this is invalid.
You have, because presumably different vocabularies, do they map to the same concept ID, or with atrial fibrillation based on ICD-10 have a different concept ID?
Yeah, it can depend. The mapping can get very complicated, and we'll get into some of these examples later on. But typically in an ideal setting, if the source codes are equivalent, then they should ideally map onto the same concept. But I'll talk about this later. Part of the complexity is that the structure of source terminologies in OMOP are not the same, and the granularities are not the same. And so mapping is not a one-to-one process, either forwards or backwards. So you have places where, again, say you have an ICD, one ICD can become more than one concept. And similarly, it's possible that you could have one concept that was previously more than one ICD. This is, again, part of the sort of semantic complexity of going back and forth between the two. And it's where you potentially lose some of your lineage in that mapping process. but I'll talk a little bit about parts of that later on too. So whereas this was sort of a more blown up key level representation of a concept, this is a snapshot of the full concept table. So you can see here, this is about 20 rows from the concept table, really looking specifically just at a portion representing ICD-10 codes. And specifically ICD-10 codes codifying a lot of poisoning diagnoses into concepts. So you can see the concept ID. These happen to be grouped together just by the concept, the random ID, the primary key. Now you can see within the domain ID, many of these are conditions going into the conditions table. There is one, row 181888, that would go into the observations table, despite also being an ICD-10. So this is another complexity. Your source terminology does not necessarily define your OMOP domain. Just because something is, say, an ICD-10 diagnosis code does not mean it will for sure go into the conditions diagnosis table. This is a complexity that I talk about a little bit later on also. And then you can get some of the other metadata here, the concept class, valid start, valid end date, and that concept code, again, that's where you're actually seeing the source code. So for instance, when you're working with raw source codes, that concept code column becomes valuable to, for instance, say, map your own definitions, in either direction onto OMOP concepts.
It seems very, very strange.
Which one?
Poisoning by enzymes assault. Especially since there's another poisoning, assault down lower that's not an observation.
Yes. The splitting of diagnoses between conditions and observation is not straightforward. And I would say also maybe even controversial. It used to be that the cardinals and bishops of Odyssey, who make things like vocabulary decisions, took certain classes of ICD codes. So for instance, contextual codes, or history of codes, things that sort of gave context of a diagnosis as opposed to a specific diagnosis. And they systematically would class those into observation as opposed to diagnosis. Over time, that decision-making, my perspective, has gotten somewhat more liberal. And so now I would say there are some things that intuitively you would think of as diagnoses going in the conditions table that now show up in observation. This is where it can get confusing to figure out, I'm looking for concept X, what table do I need to look for that in? But again, I have a solution to that I talk about later on. So we've talked about concepts. We've talked about vocab in the vocab table. We've talked at a high level about concepts and what they are and sort of what they intend to do. I think the next piece to think about is finding concepts. How does one find concepts? So, one piece is, just to go back to this slide, finding concepts in database, right? So you have the full concept table. You can do a couple of different things. You can look through source codes, right? So I think I referenced this briefly before. You can look at the actual source values if you have a list of ICD-10 codes or whatever source codes you have. You can certainly look at that concept code column. You can also look at the concept name as an actual string if there's something that you're looking for. Those are not necessarily perfect to find a comprehensive list of what you're looking for, but they are very practical, common ways that people look to find concepts. One thing to note is that the concept table is really a vocabulary structure. So it represents the comprehensive vocabulary. It does not represent the presence of these concepts in your data. So if you are finding concepts directly in the concept table, it is possible, or maybe even likely, that you will identify concepts that possibly do not exist in your data. There is another way to approach this. So I think of this as finding concepts in database versus finding concepts in data. But again, along with, I was alluding to, I would talk about this later on, such as condition versus observation. I'm going to save that approach for that slide. I do need to reference also, some people I think choose or prefer to work with concepts and identifying concepts out of the database. There are also tools online that you can use. So Odyssey has two tools in particular. Let me start with Athena. So Athena is an actual vocabulary tool built by Odyssey and available as a web app that really all that it does is facilitate searching the OMOP vocabulary and OMOP concepts. So obviously you can explore domains, you can also search the vocabulary. Now, navigating these, I would actually say take some amount of learning curve, because you get a lot of information back, and without being fairly knowledgeable of the vocabulary, it can be somewhat confusing as to what you're seeing here, right? So basically, what I've done now is I've just searched the 5+ million row table for any time the string aspirin shows up. So that result is not that useful. You can see it returned 2,252 pages of results. You can start to filter more on, say, domains. So for instance, say I'm only interested in conditions that have to do with aspirin, okay? So now I've filtered those results from 2,000 pages down into 7, and only places where these are essentially conditions or diagnostic concepts that include aspirin. And you have a variety of different filters in Athena that you can apply to these results. But for sure, I think it takes a little bit of playing around to kind of know and navigate what's happening in Athena. The next I'm going to show you is Atlas. Atlas is also a tool built by Odyssey that they have a demo of available as a web app. Atlas is intended to be a little bit more of a no-code analysis platform. And I would actually also say the learning curve on Atlas is fairly steep. However, it also offers a vocabulary searching functionality that can have some nice features. And I would say really probably instantiates the OMOP vocabulary in a way that is closer to what Odyssey intends. So I went to search in Atlas. I'm just going to go through an example of searching now. So I have searched for ECMO, extracorporeal membrane oxygenation. And now we're getting back any string that includes ECMO, which is not really what we're interested in. And so I'm going to start out just by filtering down to domain of procedure. And now within Atlas, the way Atlas is intended to work is you're supposed to load your data into it. And then it really parses it into concept pieces and then populates your data relative to the concepts themselves. So where in Athena, there is no database or data behind it. It's just the vocab. This is now vocab with some demo databases behind it. And so there are these columns that are actually showing me for ECMO, how many times do these actually show up in my data? And so Atlas can be nice in that rather than, say, just looking at the concept table and getting out nothing but theoretical concepts, these are sort of showing your concepts that are actually getting used. The other piece that can be interesting about using Atlas to search the OMOP vocabulary is when you click into it, you'll get the concept information that you would get from the row of that concept in the concept table. But you can also start to get a more visual representation of the ontology pieces. So they'll give you related concepts. And I think more helpful sometimes or interesting, you can get the hierarchy of concepts. So at the bottom of this page, it's giving me the current concept. But at the top of the page, it's going to give me lineage going up. So essentially ancestry. So my current concept has an ancestor of a more general concept, and then I can keep going up. So I've now moved up one level, and now I've gone up another level. And you can see now I've left ECMO, and I'm at the point where I'm at the most general ECMO concept, and that maps back to surgical procedures of the heart and pericardium as an ancestor. And I can basically keep doing this to navigate the vocab as a hierarchical ontology instead of as a more tabular terminology. And it is possible and also powerful to do this programmatically. So you can do this from the actual database using concept relationship and concept ancestor tables. But again, I don't really talk about those today, as those are somewhat more advanced topics to using the vocab. So after talking about concepts, it's necessary to talk about concept sets. So it would be rare that we're actually utilizing concepts individually in our research. Typically, we're using them as concept sets. So groups of concepts to define whatever thing we're interested in, whether that's a medication or a procedure or a diagnosis or some other type of event. Concept set creation can be somewhat of an art more than a science, or some blending of the two. I think even within the data science lab, each of us might have slightly different ways of pursuing concept set creation from some of the different concept finding mechanisms that I've listed. Generally, though, you need to find your concepts of interest. They might be across different tables. You might be using the concept table by itself. You might use, a method to look across tables. But then once you've identified those, you're going to compile into a reproducible list in whatever way makes sense. That might be simply as, a stored list or an array, or as a table, or some way that you can really instantiate and then use that concept list again. But then the really key piece of this is to check and check and check and check to make sure that you understand what's happening with your concept set and that you don't have anything erroneous or potentially really significantly detrimental included in your concept set. And so I want to go back now and say, I have this image on the right, this union representation. So the way that I really pursue identifying concepts and building concept sets is, rather than going from the concept table down, I typically create a union structure of all the actually used concepts within each of the clinical data tables into a sort of new actually used concept sort of terminology table, independent of the vocabulary concept table, right? So rather than being a comprehensive list of concepts, this is just the list of concepts that are used in whatever data set that we're looking at in the database. And then we'll also calculate frequencies and distinct patients so that we can get a much better, clearer sense of, one, when we're looking for concepts, what domains are they in? So do we potentially have a definition or a concept set that spans across multiple tables? So, for instance, do we have a diagnostic concept set that spans condition occurrence and observations? But it also lets us prioritize concept set or concepts within concept sets. So how frequently is a concept used? Are there concept sets that can sort of, be trimmed, or can we get a little bit more parsimonious with the definition? And I think that this structure we use commonly enough now that, at least in some of our public facing data sets and OMOP databases, we have this structure built. So for instance, in ordered, we have a research resources schema that has, for instance, this structure already built to utilize for people for identifying concepts and building concept sets. And then, as we would sort of build out other databases that are user-facing in OMOP, we would tend to do the same thing as part of the research infrastructure. And it's worth showing creating concept sets in Odyssey tools. So you do have the ability to create concept sets in something like Atlas using their vocabulary navigation. So this is an example of looking at a pre-built concept set for myocarditis enteroviruses. You can see here, that concept set exists. It has these 3 concepts built inside of it. And interestingly, there are some more power tools that exist in these GUIs, right? So you can see, for instance, on those concepts, they have include descendants checked. And so while only 3 concepts are sort of identified in this, were we to say extract the code for this, or hit the export button to export a more text-based list, it would include many more concept IDs than just these 3, since we're inheriting all descendants of these codes. So moving now into sort of part of the final topic of just thinking about, as you start to work with the vocabulary in OMOP, what are some of the initial foibles and issues that you have to be aware of? So one piece is concept versus source code. I think, to me, this is the most common question and point of concern for early users, which is, why even bother using the OMOP vocabulary? If source values exist, why not just use it, right? So I'm a health services researcher. I've got 10 billion lists of ICD codes. Why don't I just use all of those? Part of this is an easy question to answer, and part of this is a hard question to answer. I'll start with the hard piece. So part of this comes down to, in my opinion, OMOP orthodoxy. So from the point of view of Odyssey, their vocabulary is intentionally designed to reduce the amount of knowledge and labor that is required to work with the diverse set of source terminologies. So while you may be an expert at, say, ICD-10 data representation, you might not be at HCPCS level 1 and HCPCS level 2 and LOINC. And rather than gaining a huge amount of knowledge and experience with those source terminologies, this is a way of centralizing and standardizing it across, all of those into one standardized terminology. So it potentially offers up a less steep learning curve for understanding and utilizing all of these different terminologies. Another piece is, obviously, it's an ontology as opposed to a terminology. So from an organization theory perspective, there is a lot of more powerful and sophisticated relationships that can be represented and programmed against than a terminology. And so this is where, I think I said at the beginning, I think OMOP is a very informatics and information theory forward modeling system. And I think this is where some of this OMOP orthodoxy comes in. So I would say if you go to Odyssey meetings or, participate in their open groups, you're really, I think, going to encounter a view that like everything is mapped onto concepts always, because that is the really optimal way to codify data, particularly within OMOP. I would say there is also, outside of orthodoxy, a bit of a reform movement where there's a feeling of you should be doing what is practical, and sometimes what is practical or necessary does not exist strictly within the confines of OMOP concepts, and then you should look at using source, and that is fine. I feel like this truly is a bit of a philosophical difference, right? This is the hard part of why should you use concept versus not. The easier part are really some other pieces of this. So one, for instance, in harmonized networks, typically source is not required if you are bringing in native OMOP data. So for instance, in N3C, which uses OMOP as its source data model, if a site was not mapping onto OMOP, if they were a native OMOP site, they did not have to bring in source. So within N3C, we had several sites that simply had no source values whatsoever. Their data only existed in OMOP concepts. And I think that is not an unusual standard for OMOP-centric data networks, right? So one answer is you might not have a choice sometimes, particularly in standardized, harmonized networks. Another piece is that if you want to get the power out of OMOP as an ontology, you really have to use concepts. You can't use source, right? So when you want to get into things like programmatically saying, I want to identify every medication and I want them to have this ingredient, you either sort of have to do something like define 10,000 NDCs where that is the ingredient, or you can write a couple of lines of code utilizing the OMOP ontology, but that requires using concepts. Another big piece is that as OMOP integrates across something like 80 vocabularies, source values get recycled across those terminologies because terminologies are developed out of sync with each other, right? So here's an example at the bottom of the screen. If you were sort of to naively just query the concept table for give me back concept 1001, that occurs across a bunch of different terminologies. And so you will get multiple rows back based on that concept value. And so it is potentially dangerous to use concept unless you're very careful at your checking to make sure that your concept codes, your source values are not getting recycled across terminologies and bringing in unintended concepts. So another piece to talk about, inheritance within OMOP can be dangerous. I think a sort of early to medium level assumption that people make is that inheritance is awesome within the vocabulary, and I'm going to pick a concept and inherit all descendants, and it resolves any issue that I have with ever looking at much more granular codes. Well, that is theoretically correct. It not infrequently leads to pulling in a bunch of stuff that is just wrong. And this is a surprisingly common problem to make. So on the left, I kind of have this, pet example of this ontological representation of a vocab, an OMOP vocab situation, where at the top we have these sort of clinical areas of respiratory allergy issues, as on the same level as COPD. And you can see that both of those inherit through lineage this symptom category, which then inherits both rhinitis and sinusitis. And through the rhinitis, you get down to allergic rhinitis and seasonal rhinitis. And that might be fine if you're taking the respiratory allergy and inheriting descendants. But if you take something like COPD and inherit descendants, what results is that you wind up pulling allergic rhinitis and seasonal rhinitis into your grouping of COPD. And that is, in fact, a real mapping issue that shows up in an Odyssey package. So when in the past, we've spent a lot of time calculating Charlson in N3C data or in OMOP data, there is an Odyssey developed package that allows you to, sort of their stored code to just calculate Charlson and defines it in concepts, but it inherits descendants across Charlson groups. And literally within N3C, the COPD Charlson group inherits descendants all the way down to chronic sinusitis and allergic rhinitis pollen and pulls in millions of people to COPD, where their only concept are these completely unrelated things, right? It's simply erroneous inheritance. So same thing, right? Diabetes without complications, gestational diabetes maps up to that, and dementia, you can pull post-concussion syndrome in. And so that's particularly on a large database or network data system, inheriting descendants can be powerful, but also very, very dangerous. So I think you want to spend some time making sure you understand how lineage works and how to navigate it. And also, again, like I was saying before in building concept sets, you want to check and you want to check again and you want to check again. I think another intro concern to be aware of is that source to concept mapping can be problematic and is not one-to-one. So examples of this are that the granularity between source terminology and OMOP can be different. So I have here a sort of brief ICD-based example. So we have an ICD code of M17.9, osteoarthritis of knee bilateral. Well, that concept code might not exist. And it might not exist possibly because in OMOP, it exists as two discrete concepts. And so this is a place where you could have a complete ETL level mapping of one single ICD code into two concept codes. And this can happen in lots of places, right? So this is a sort of intended mapping difference within source to OMOP. And then sometimes you can also have the opposite, right? So for instance, say we had, this example, but the opposite. Say we had an ICD of osteoarthritis of knee, but it included multiple anatomical locations, and we had a concept that combined all those into one. That's where you can see this many to one relationship backwards and forwards in the mapping. So it is not ever a safe assumption to say the ICDs I have on, this table are going to map exactly one-to-one to the concepts I have on this other table. This is a complexity in OMOP. The other piece that can sometimes come up as an issue is the actual raw mapping, right? So not the intended granularity differences that can split, but you can also sometimes just wind up with mapping issues. So for instance, I saw this recently when I was building a concept set related to pregnancy and using preeclampsia as an indication of being pregnant. I noticed that I was pulling men into my cohort. Why is that? It was because through an OMOP concept relationship, benign essential hypertension was getting linked to preeclampsia in certain situations, right? So like this is likely just a raw mapping issue between source and concept. So I think, again, you want to be careful, and it's important to check in your cohort, in your results, what you're actually getting back when you're doing your concept set building and your phenotyping and your cohort building. And so just to finish up the lecture portion, I wanted to point out several resources, both for getting up to speed with OMOP as well as the OMOP vocabulary. So as any religion, OMOP does have a referential book. Theirs is the Book of Odyssey. It is available online, essentially as an online book or essentially in like book down format. Chapter 5 is on standardized vocabularies. You can just Google the Book of Odyssey and get to this online pretty easily. The Eden Academy is another online site. I believe this is actually essentially like a recognized training partner of Odyssey. They are in the EU, so some portion of this might be slightly more EU-centric than American-centric, but this is actually just a full online training course for OMOP and the OMOP vocabulary. The full course is fairly lengthy. I want to say it's 7 or 8 hours of essentially videos, but this is often put out as like the initial sort of major learning kind of introduction for getting up to speed with OMOP in a sort of more didactic way. There's Athena Online, which I pointed everyone to. There's Atlas Online, which this is the link to the demo. And again, I think I've referred to this a couple of times, but if we get to the point of doing a more advanced OMOP vocab topic, I mean, I think it would probably, I can take suggestions on this, but, two things that come to mind initially are certainly really getting into the nitty-gritty of mapping details, both on the informatics side as well as on the analytics side, I think is a value, as well as really starting to utilize the ontology, probably both from more of like a theoretical informatics standpoint, as well as from an applied programmatic standpoint, right? How do you program against the ontology to use that to do things like find concepts and define concept sets? But if there are other topics that you think require or would benefit from more discussion, just send them in to tdsl@unc.edu, and we can look at adding those as future seminars. And with that, let me just move on to questions and discussion. Stop share. And I think because this is a webinar, I think you have to raise hands to be manually unmuted, or you can put any questions in the chat. So I guess I'll ask any questions or other topics in the room.
Maybe a little more detail. So what is a class? See a concept class ID.
Concept class ID. Let me, oh no, my battery is running low. Yeah, do you mind? Oh, thank you. Oh, yeah, discharge. Let me pull the slides up again real quick so everybody can see. Okay, so the question is concept class ID. Typically that is basically telling you within a terminology, like what type of information is being codified between source and the concept. So within, certain terminologies, it might be telling you like, in a pretty categorical way, like this is the type of information. So like here you can see within UCUM, the concept class is units, right? Because that terminology, all it's doing is defining units for measurements. But across, and that often happens on OMOP generated vocab components also. But then in sort of more specific terminologies, it might tell you within that terminology, like what the more like applied use of that code is. So like within ICD, it's often telling you, so like here, they're telling you it's a 6-character non-billing code, but oftentimes it'll tell you this is a 3-character code, right? So is it more general? Is it less general? But it's usually conveying some amount of information about like what is the content being codified between source into concept here. Yeah. Yep. Oh, okay. Any other last minute questions from online? I'm not seeing anything. Yeah. All right. Well, great. Thanks everyone for attending. We look forward to seeing you for our February seminar, third Tuesday, February, in tracks 219 at 12:30. Thanks very much.